Hello guys, my name is A.A Benjamin, member of A.I.A. I'm here to take you through qualitative analysis, and we are going to test for 2 cations and 1 anion. So we have been given a set of instructions to follow, and we have been given solid E, which is here. This solid E, as you can see it, this is solid E, it's white in color. So we are going to start our procedure, and they have told us to a spatula endful of E in a test tube. Actually, the test tube you're using should be clean, purely clean, without any other chemicals or any other substances in it, so that you can attain clean results. So they have said to a spatula endful of E3 in a clean test tube. This is our clean test tube. So this is our spatula. We are going to get 1 spatula and put it in a clean test tube. So do not eat any of these chemicals, whether it looks like something, whether it looks like salt, whether it looks like sugar. Do not temper to taste, because these chemicals look like what we use at home, but in actual senses they are different components. So we have put 1 spatula in a test tube of solid E, and now they have said add 4 centimeters cubed of water and shake strongly to dissolve. So as you can see, this is our water, clean water, and we are going to measure 4 centimeters cubed, and we are going to use this measuring cylinder to measure 4 centimeters cubed. And so this is our 4 centimeters cubed, and we are going to add it to our solid we put in the clean test tube. So after adding, they have said shake strongly to dissolve. So we are going to shake strongly, that you shake strongly so that you get clear results. If you don't shake strongly, your results will not be clear. Why? Because the solution may have not dissolved the way they want it to dissolve, hence giving you wrong results. So if they tell you shake strongly, you must shake strongly. Then as you can see, after shaking, we have obtained a white solution. This white solution, they have said to the resultant solution add up your sodium hydroxide dropwise and shake strongly. So we are going to add our sodium hydroxide, which is here, but we are going to add dropwise. As you can see, I'm doing it. So they have said until in excess. So you make sure you add the sodium hydroxide. As you can see, as the more sodium hydroxide we keep on adding, the solution keeps on turning to brown.
Purchase your tracks today.
We shall get our filter paper. This is the filter paper, and let me show you how to use the filter paper. You fold it like this. This is how they fold it. Then you fold it again like this. As you can see, fold it like this to make a cone. Then after folding it, you open one side like this. So this is our filter paper, and after opening one side like this, then you're able to put it in the funnel. So like that, in that way. Now we are going to filter. So we shall use our cylinder. Then So we have obtained our filtrate after filtering, and our residue is brown in color and our filtrate is colorless. So as you record in your observations, you say after filtering, a brown residue was obtained and a colorless filtrate was obtained. So this proves to us that there could be some cations that dissolved to form a colorless solution. So these cations could be the cations that usually dissolve in sodium hydroxide are already three. The first cation is zinc, 2 ions. The second is aluminium, 3 ions, and lead 2 ions. So when we are recording in our deductions, we shall say zinc 2 ions, aluminium 3 ions, and lead 2 ions are suspected present. But we have also obtained a brown residue, and this brown residue is always of ion 3. It's already like when you mix sodium hydroxide with ion 3 ions, they will form a brown residue. So we shall also include ion 3 ions in our deductions suspected present, because we don't know what exactly is in our solid that we are provided with. Now they have said to the filtrate obtained in A above, add dilute nitric acid drop by drop until the solution is just acidic. So this is our dilute nitric acid. We are going to add drop by drop. I think we shall transfer our filtrate in a clean test tube. So this is our filtrate. We are going to add dilute nitric acid drop by drop until the solution is just acidic. So as you can see, when we add drops of dilute nitric acid, we are getting white precipitates. So when they say until the solution is just acidic, which means we are going to add dilute nitric acid until these precipitates disappear and the solution becomes just colorless. So divide the acidic solution into 5 portions. So to prove to you that this solution is acidic, I'll test it with blue litmus paper. We normally use blue litmus paper to test for acids. So I'll use my blue litmus paper, which is here, and try to put it in the solution I have. You can see it's acidic, which means our solution is already acidic. We have made it acidic. So they have said to the first portion, they have told us to divide this solution into 5 portions, and they have said to the first portion clockwise until it appears sodium hydroxide. We are going to get our clean test tube and get the first portion. This is our first portion, and they have told us to the first portion add sodium hydroxide dropwise until in excess. So this is our sodium hydroxide, and we are going to drop until in excess like they have told us. You can see as we are dropping, seeing some white precipitates. Those are the white precipitates that we are obtaining. See, but these white precipitates disappear with time. When you drop, see, the white precipitates, they are there, but when you we have obtained a clear solution. What does this show to us? It shows to us that there are already 3 cations that usually form a precipitate with sodium hydroxide, and the precipitate is always soluble in excess. That is zinc ions, aluminium ions, and lead 2 ions. So here, as we are recording in our observations, we shall say the white later dissolved on addition of sodium hydroxide in excess. What does this show to us? It shows to us that there could be presence of zinc 2 ions, aluminium ions, and lead 2 ions. So in our deduction, we shall say zinc 2 ions, aluminium 3 ions, and lead 2 ions are detected present. Second portion. Now we are going to get the second portion. You get a clean test tube and you get your solution. We are going to get the second portion. Yes, this is the second portion, and they have told us to the second portion add aqueous ammonia dropwise until in excess. So we are going to get our aqueous ammonia, which is this. This is our aqueous ammonia solution. So, or dilute ammonium hydroxide. So we are going to add until in excess dropwise. So as you see, there are some precipitates that are being formed and they are white. As you can see, we are obtaining white precipitates. The white precipitates forming, so we should add until in excess until we see no observable change. As failed to dissolve, we know very well that from our first results, we found out that zinc 2 ions, aluminium 3 ions, and lead 2 ions form a precipitate with sodium hydroxide, which is soluble in excess. But now, in our aqueous ammonia, we have formed a precipitate, but the precipitate is insoluble in excess. This shows that there could be aluminium or lead 2 ions present in our solution, because the aluminium and lead 2 ions do not dissolve in excess aqueous ammonia. They just form a precipitate that is insoluble. So this shows to us that aluminium 3 ions and lead 2 ions have been detected present. So they have told us to the third portion, add 2 drops of potassium iodide solution. This is our third test tube. We are going to add 2 drops of potassium iodide solution. These 2 drops, 2 to 3 drops of potassium iodide solution. Remember, potassium iodide solution reacts with lead 2 ions to form, but when it reacts with aluminium 3 ions, it doesn't form. There is no observable change. So let us see. This is our potassium iodide. Say 2 to 3, 1, 2, added, but the solution is still colorless, which means there is no observable change. So this is the confirmatory test for aluminium ions. In our deductions, we shall write aluminium ions confirmed present, because when sodium iodide is put into aluminium ions, there is no observable change, and it's what we have observed here. There is no observable change. As you can see, the solution is still colorless. So we shall write aluminium ions confirmed present. That's our first cation we have confirmed. Now you have told us to the fourth portion, add 2 to 3 drops of V2 nitrate solution and warm. So add to the fourth portion, we are going to obtain. They have told us to add the first portion, add drops of V2 nitrate solution and warm. So we are going to add V2 nitrate. This is our V2 nitrate. 2 to 3 drops. 1, 2, 3. So we are seeing a white precipitate has been formed in addition of 2 to 3 drops of V2 nitrate. So they have told us to warm, not to boil but to warm. So when you're heating or warming, make sure the test tube is a little bit bent. I think we have warmed, but after warming, we are seeing that the white precipitate has not dissolved. It is still there. Solution is still white with the white precipitate. This shows us that there could be sulphate ions present in this solution, because sulphate ions form white precipitate which is insoluble with lead to nitrate. So they have told us, so in our deduction you write sulphate ions suspected present. We haven't confirmed yet whether they are present. Now they have told us carry out a test of your own choice to the fifth portion to confirm ammonium, to confirm the anion present in E, the sulphate ions to be present. So we shall carry out our test. To check whether we have sulphate ions in our solution. So to test for sulphate ions, we normally use barium nitrate. So we have here barium nitrate. This is our barium nitrate. We are going to add barium nitrate. As you can see, sulphate ions form white precipitate with barium nitrate. And our white precipitate is insoluble in barium nitrate. See? It's insoluble in barium. We shall write sulphate ions confirmed present. So we have confirmed so far 1 cation and 1 anion. The first cation we confirmed was aluminium 3 ions, and the second cation, the anion we have confirmed is sulphate ions. So like I said, we are going to confirm 3 cations and 1 anion. I mean 2 cations and 1 anion. So they have given us another instruction. They have told us wash the residue obtained above the aqueous sodium hydroxide and dissolve. So this is our residue we kept. We are going to wash it with sodium hydroxide. So we shall just add it inside here. Now we have washed our residue in sodium hydroxide. Now they have told us to dissolve it in a minimum amount of dilute hydrochloric acid. So we are going to get it out of the filter funnel that way. Dilute hydrochloric acid. So, I said we dissolve it in a minimum amount. Now we have dissolved it. I'm going to put it in a clean test tube. This is it. We have obtained a brown solution. Now they have told us divide solution into two parts. We are going to divide the solution into the two parts. So this is a clean test tube. We are going to divide the solution into two parts. And then they have told us to the first part add aqueous sodium hydroxide dropwise until in excess. So this is our sodium hydroxide. As you can see, when we add sodium hydroxide, there is a brown precipitate which is formed, and this proves to us that we have got iron 3 ions in this. We have got iron 3 ions in this solution. And now they have told us when you're writing your deduction, you say iron 3 ions present, because we have confirmed it here by adding sodium hydroxide to form a brown precipitate and a brown solution, showing us that there are iron 3 ions. And then they have told us to the second one, add one small piece of zinc granules and leave the solution to stand for 5 minutes. So these are our zinc granules. You can see them. These are the zinc granules. They have said you pick one. Okay. Now they told us to the second portion to add zinc granule. They told us to add one small zinc granule, and we have added the zinc granule. So they told us to wait for 5 minutes and then we take the solution to test. So we shall wait for 5 minutes. We had a yellow solution, but now it has turned to a green solution. You can see it clearly. You can check on the first one and look at this one. They are different because this one has turned from yellow to green. Remember, when we have iron 3 ions, they are either brown or yellow, and iron 2 ions are always green. They form green solutions, which means when you put the zinc granule it reduced iron 3 ions to iron 2 ions. So this, which means this solution contains iron 2 ions, if I'm not mistaken, because we're going to take it for a test. But you can check from the first appearance and the second appearance, they are quite different. So they have told us divide the solution into 2 portions. So we are going to divide the solution into 2 portions. As you can see, we have two portions, and they said the first portion, add aqueous sodium hydroxide. So this is our sodium hydroxide. They have said drop wise until in excess. So that's our first drop. You can see as we are dropping, there is a darker green forming. So you can see, and the darker green is insoluble in excess sodium hydroxide. You can see. So this proves to you that the iron 3 ions have been reduced to iron 2 ions. So as you write in your deductions, you say after obtaining results of the zinc granule, you say the yellow solution turned to green solution in your observation, and in your deduction you say iron 3 ions were reduced to iron 2 ions. So when you have divided the portion, the first portion, you have tested it with sodium hydroxide, and you have got a darker green precipitate. So in your deduction you write a darker green precipitate. In your observation you write a darker green precipitate, and in your deduction you write iron 2 ions present. And now they have told us to the second portion, add aqueous ammonia. So this is our aqueous ammonia. So until in excess, drop wise. As you can see, it's also forming a darker brown solution, a darker brown precipitate. You can see it. You can see it. It's a darker green precipitate. This confirms that we have iron 2 ions present in our solution. So, like the first time we obtained iron 3 ion, we got iron 2 ions present in our first solution when we used sodium hydroxide, and in our second solution we used aqueous ammonia, and we got darker green precipitates. You can see them. This is enough proof to show us that we have iron 2 ions in our solution. So if you've been following very well, the first cation we got was aluminium 3 ions, and we followed by getting the anion, which was sulphate ion. Now our last test, we got iron 2 ions, but in our solution we had iron 3 ions, where we used zinc granules to reduce them to iron 2 ions. So we had to get iron 2 ions in our solution. Thank you for watching.